Okay, so this is the basic rule here. We have x to the a over b power. This is the exponent. It's a fraction. It's a rational number. And so what we've looked at so far is when the numerator was 1, but it doesn't have to be 1. So if it's not 1, that number just kind of stays here as an exponent with the x. And again, our denominator goes to becoming the index like it did before. And so we're going to look at a couple examples. And this first example here, 27 to the 2/3 power. So the definition of a to the m over n. And so let's look at what this definition is. I don't see it here. I'm going to show you where you can go get it. So right now, we're just going to go into HMH real quick. And you should be able to access your entire textbook digitally. Okay, and so I'll show you how to do that in case you forgot. Once you log in, you have your resources. You go to Student Resources. And then these are all of the units in the text. We are in Unit 6. And we're on Module 14 because our lesson is 14.1. So if I click on Module 14, then that pops up 14.1. If I click on this, there's a bunch of things here to help you. All right, but the edition, the student edition is here. There's also a Spanish student edition. If you wanted to take a look at that, you can do that. Okay, so if I go to the student edition, this is where we're at, understanding rational exponents and radicals. And so when I make these lessons for you guys, I kind of pull out the most important stuff and try to kind of summarize it for you, but you can go back and read the lessons too. I'd actually encourage you to do that. So we covered this on Tuesday, that anything raised to the 0 power is 1, except for 0 to the 0 power is undefined. When you raise something to a negative power, then you change it into 1 over that power where the exponent then becomes positive, or the opposite sign. We looked at this rule. The nth root of a is equal to a to the 1 over n. Okay, that's what we've practiced with so far. You can see these are the same problems that we did in the Pear Deck. They're just right out of the text. So, you know, if you have the textbook, the physical copy of it, when we're doing the Pear Deck lessons, you know, you can take your notes by just writing all in the book. It's a consumable. You don't have to give it back. It's yours to keep. Here's where we're at today. So we're looking at the rule here that a to the m over n is equal to, you can kind of separate the 1 over n fraction from the numerator of m, and then keep that on the outside and use the previous rule to turn this into the nth root of a, where m is on the outside. Or you can take a over m to the n, separate it again, but this time we're moving the fraction 1 over n outside, and we're keeping a to the m inside the parentheses. And then we would take the nth root of this entire thing where a to the m becomes the radicand. So it could be written 2 different ways. And I am going to put that, and I would like you to also copy that, okay, into this. Okay, so lots of windows, sorry. But I'm going to go ahead and come over here and copy that. So, you know, it says the definition of a to the m over n. And if you start writing and it's huge, you need to change the size. And it always defaults back to some random size there, so you always got to make it smaller. A to the m over n is equal to, and so after you do all this, it turns out that it's equal to, in parentheses, the nth root of a all to the m power. That's one way to write it. Another way to write it, or it could be equal to, you have over here, there's no parentheses, and now the radicand has the power of m. So it works both ways. And I like this little picture here. They're using different letters. Instead of A, M, and N, they're using X, A, and B, but it's labeling the different pieces. So you got the radical symbol, the index, the exponent, the radicand. But for this work here, we're going to use the definition of A to the M over N. So when you do that, what this is going to turn into, you can see how they're using it in this example. They're using this top version, right? So they're going to turn this into the nth root of A in parentheses, all to the M power. And so when you're doing this, you can think of this numerator here, comes out here, and it's the exponent. And then your denominator here becomes the index. All right. The denominator became the index before. The only thing that's different is now we have a numerator to move, right? Before the numerator was just 1, and we would move, if you move a 1 there, it doesn't change the value of anything, so we didn't write it. Okay, and so once we use the definition to change this power into a radical expression, then we can rewrite the radicand as a power. Our radicand is the number that is under the radical sign, and so in this case, 27 is our radicand, and 27 is the same thing as, well, because this is a cubed root, there's an index of 3, we want to rewrite 27 as a cube, all right? And so 27 is actually equal to 3 times 3 times 3. So because of that, that is why we can then take 27 and rewrite it as 3 to the third power. Then what they do is they're using the definition of a cube root, which means we're taking the third root of something to the third power. So the third root and the 3 exponent like cancel each other out, and you're just left with the 3. But then you still have this 2 out here, and so this 2 comes and sits right here. And so 3 squared, last step, you just simplify that. 3 squared is the same as 3 times 3, or 9. All right. And so we are going to now look at doing part B together. So on your pear deck right now, I can see there's 10 of you that are writing on this slide. Everyone should be writing on this slide. You should be copying what I'm doing onto your slide. So you should have the meat in a window and have the pear deck in a window side by side. Or you could have the meat on your phone and then have the pear deck on your Chromebook. Okay, there's lots of ways to do that. You know, maximize whatever devices you have at home to kind of help you do this the best way possible. All right, 25 to the 3/2 power, the definition of A to the M over N, right? So again, we're using this. And so we're taking 25 to the 3/2 power. This 2 is in the denominator. And just like last time, when 2 is in the denominator, it became our index, right? Now, if it's 2, you don't have to write it. But we can write it. It's not going to be wrong to write it. We're just going to write it. And then what number will go in this little box here? So I'm going to see what you guys are coming up with. What number are we going to put in this little box right here? I'm going to show you responses. Those of you that signed up to retest today, okay, you filled out that form like I asked you to. If you wanted to start on that test now and then just watch the video to this later, I'll let you do that. If you filled out the form, there was, not everyone filled it out, but so like Adrian, Isaac, Lillian, Bree, Esmeralda, okay, the 5 of you, if you want to go ahead and start on Otis, it's assigned to you and you can start retaking the test. But you can kind of like listen into at the same time. It's up to you. You can wait. You can wait and just keep testing after school. If you want to sign up to retake it, then in our week at a glance, it was this form on yesterday. You had to fill that out. All right. So what are we going to put in that little box? Did we figure it out? Not 34. What's the numerator of my exponent right now? So if I look at what my numerator is, I have a 3 right here. The 3 needs to go here. We're going to put a 3 here. Okay. So that's using the definition of a to the m over n. Our next step is to rewrite the radicand as a power. Okay. The radicand is 25. So 25 we're going to rewrite as a power. And we want the power to match the index. The index is 2. So we want to rewrite 25 as something squared, right? What's 25 the same as something squared? It's in Otis. We go to Otis. So Adrian, I saw your message, otis.com. Yeah, so some of you guys did fill out the form and you said you needed some extra help before you can take the test. And so I am going to help you guys today during your async time. And today's not the only day you could retake the test, so don't stress. You can retake the test any day during the semester. You just have to do something that proves that you're like more prepared to take it. Okay, so I'll explain that more once we're done with the lesson here. So what number can I put here? What am I squaring to get 25? One's coming up with it. So you can just write it on your Pear Deck slide. What would I square to get 25? Aha, here, this person figured it out. 5, absolutely. Okay, 25 is the same thing as 5 to the second power. It's the same thing as 5 times 5. So in this box, we are going to put a 5. And in this box, we're going to put a 2. Okay, because we took 25 and rewrote it as 5 squared. So 5 squared. What goes in this little box out here? One has it yet. It's just the same number. Nothing's changed. I'm just taking this number here and I'm just writing it over again. 3. Still just 3. It's just following along. Right? This 3 again is going right here, right? And so we rewrote the radicand as a power. And now we're going to use the definition of the what root. Well, what kind of root is this? When you don't see that index written here, there's an invisible 2. And what do we call, it has its own special name right here. What would I write? What is this? This is the what root. What do you call a root with the index of 2? A what root? It's a word that we need to write. I'm going to type a word in there. You can type it on your Pear Deck. You can type it in the chat. I don't know. Well, up here, this one was called a cube root because there was a 3. Now, when there's a 2, this is called a what root? Nobody has it. Okay, it's a square root, guys. That's what you call it. So when your index is 2, this is a square root. You're going to put the word square in that box. That is a square root. Square root has an index of 2, whereas a cube root has an index of 3. After you get to higher numbers, like a 4th root, they don't have their own special names anymore. You just say the 4th root, the 5th root, the 6th root. So definition of the square root, though, that means if we're taking the second root of something that's squared, we just get the 5, and that's where this 5 comes from. Okay, so we did that. And then the very last step here is to fill this in. What is 5 to the 3rd power? What is 5 to the 3rd power? It does not mean 5 times 3. It means 5 times 5 times 5. That's what 5 to the 3rd power means. We're multiplying 3 times
125.
It is 125. Perfect. So that's what's going to go in the last box, 125. There you go. So that's how we do these problems, okay? And so if your numerator happens to be 1, you don't have to worry about this little floating exponent going around with it. If your numerator is something besides 1, well, then you keep it on the outside and deal with it at the end. Okay, and that's kind of what we showed here. Okay, so I am going to do this. So I know a lot of you guys are copying on this slide right now, so I'm going to put it on student paste. All right, but what I would like you to do is go forward to the last slide, slide 8. And I'm going to leave, I'll leave this up in case you're copying. But what I would like you to do is work on the last slide, slide 8. Okay, I'm going to give you some time to do this. And you know, if you're not exactly sure how to do it, do what you do understand. Do to the problem what you understand. You know, maybe it's just writing, maybe it's just writing down the first step. Maybe it's just writing this. And I'll write that on here too, but I need to keep this here for this time being. So I'm going to give you some time right here to do that. I'm going to check on those that maybe already started with the Otis test and see how they're doing. Okay, so I have 3 of you that have started writing on your slide. I come over here, you know, maybe I just want to write down the rule to start with. That A to the M over N is equal to, put a radical symbol, we put the A in the radical as the radicand, the denominator becomes the index, and the numerator becomes the exponent. You can put in the parentheses or not. They don't have to be there. Okay. I'm up to 6 people writing now on this slide. So I'm going to force you to be on this slide. So go to this slide, start writing something. All right, so time is up here. I got 11 of you to reply. So if I show some responses, okay. So they're like in the middle. This person wrote the formula. This person has put the index where it should go. You know, as you're doing this, if it's really confusing or this is hard, and that's an honest feedback, and I appreciate you telling me that. Here's one thing you can do. So we have this formula, right? I don't know if this is going to make it more complicated or less complicated, but I'll show you another thing to kind of help you organize your thoughts. You don't have to do this, but it might work. So we have 3 variables. We have A, and that's going to equal something. We have M, and that'll equal something. And we have N, and that'll equal something. So maybe to help you figure out what you got to do here, maybe what you want to do is look here and figure out what each variable is represented by. A is 32. Okay. M is 3. N is 5. Okay, so you can do it this way. And then now that you know what the numbers are, you would come to this side that we're trying to transfer it into and basically put the symbols, like the radical symbol and the parentheses there, and then use this to help you fill in the numbers. Okay, so like if I just put in the parentheses and the radical symbol, right? And now I'm trying to figure out what goes where. Then maybe it would help to see here. Okay, so A, the radicand is 32. M, the exponent, is 3. N, the index, is 5. Okay, and then that way I've gone from here to here, and maybe that helps me organize my thoughts. Okay, I don't know if that helps. You don't have to do this extra step, but maybe it would help you kind of see what you have to do. All right. I like how this person's making a really awesome square root symbol. That's great. Okay, so that's one thing you could do. That might help you. Once you get to this point, like we did on the last slide, so I'm going to put this back on student pace because I don't want to change everything. But on the last slide, okay, after we wrote it as this, then we rewrote the radicand as a power. All right, and we're going to do the same thing here. We're going to rewrite the radicand as power. The radicand is now 32. So now I'm thinking, how do I rewrite 32? 32 is the same thing as a lot of things, right? But you know, because the index is 5, I'm trying to think of what 5 numbers can I multiply together to give me 32. Do you know what 5 numbers multiply together that are the same number that equals 32? Seeing if anyone came up with it. It's a small number, relatively speaking. So 2 to the 5th power is equal to 32, because 2 times 2 times 2 times 2 times 2 times 2, okay, that is 2 to the 5th power, okay? And that's what you want. You want this number and this number to match, okay? And these problems are set up so they are going to match, okay? They're meant to work out for you as you're learning something. And then we're going to replace 32 with 2 to the 5th power. Okay, so if I just write parentheses, the radical symbol, I'm going to put the 5 here, I'm going to put the 3 here, and now instead of 32, I'm going to write 2 to the 5th power. All right, and then we're going to simplify this using the definition of a 5th root. The 5th root of something to the 5th power, they cancel each other out, and what I'm left with is 2 to the 3rd power. And 2 to the 3rd power is what? This just means 2 times 2 times 2, which is the same as what number? What is 2 to the 3rd power equal to? Not 6. Now do 2 times 3. Do 2 times 2 times 2. 8. There we go. Someone got it. 8. It is 8. So 8. Highlighter. It's highlighter answer. So the answer is 8 for number 5. Number 6, even though there's 2 powers in it, this one's actually a little bit easier because, you know, by our rule, when the denominator is 2, which we happen to have here on both of these, this means we turn it into a square root. And when it's a square root, you don't even have to write that index of 2. It's implied. All right. I'm not going to write out these steps here this time. Okay, I did a lot more work than what you have to do. From this point right here, this turns into the square root of 4. The 2 goes here, even though you don't have to write it. The 5 is out here. You don't have to put the parentheses either. Minus 4 goes into the radicand. The 2 becomes the index. The 3 becomes the exponent. Rewriting 4 as 2 squared to the 5th power minus 2 squared to the 3rd power. Square root of 2 squared, The square root and the square cancel each other out. You're left with 2 to the 5th power minus, again, the square root and the squaring cancel each other out. You're left with 2, and the 3 is still here, so 2 to the 3rd power. We've already figured out what both of these powers are in this last problem. What's 2 to the 5th power? That number. What's 2 to the 3rd power? That number. So it's that number here minus that number here. 32 minus 8, which is 24. Right? Do you have questions on this? Yes, Angela was 8. This is the end of the lesson.